All right, so we're going to conclude section 6.2 with one last example. The nice thing about this example is it's going to give us kind of a reminder of the difference between finding our probabilities and finding our inverse normal values. Right, so according to the National Health Center, the heights of 6-year-old girls are normally distributed with a mean of 45 inches and a standard deviation of 2 inches. In which percentile is a 6-year-old girl who is 46.5 inches tall? All right, so we're going to start by sketching our curve. All right, our mean is 45, our standard deviation is 2. So we're going to add 2 as we go to the right, subtract 2 as we go to the left. Right, and we are asked for in which percentile is a 6-year-old girl who is 46.5 inches tall. We're looking for a percentile, so we're looking for a probability. Right? So this is going to be a normal probability problem, and we're going to use StatCrunch to determine the probability. Right, so if we were to sketch in our curve, we would draw a little line where we see 46.5 would be. And then we're going to shade our area to the left because percentile is always area to the left. Okay, so there is our curve shaded. Then we're going to go into StatCrunch, and what we are going to do, we are going to enter our mean. Our mean that we're going to enter is going to be 45. We are going to enter our standard deviation. Our standard deviation that we're going to enter is 2. Right? We're going to leave it on the standard one. We're going to select our less than or equal to symbol, and then we're going to type in 46.5 because that's the value that we're looking for. Right, and then the answer that it's going to spit out, this is our answer that we are looking for. So this gives us 0.77337265, which we are going to round to 77%. So a 6-year-old who is 46.5 inches tall is going to be in the 77th percentile. All right, so for part B, if a 6-year-old girl who is 46.5 inches tall grows up to be a woman at the same percentile of height, what height will she be? All right, so assume they are normally distributed with a mean of 64 and we have a standard deviation of 2.5. So first thing I'm going to do is sketch our curve. So here's 64. We add 2.5, 66.5, add 2.5, 69, add 2.5, 71.5. Go back to 64, subtract 2.5, we get 61.5. Subtract 2.5, we get 59. Subtract 2.5, we get 56.5. Right. Then here, this is going to be an inverse normal problem, because we are using our answer from part A, right? If a girl who is 46.5 inches tall grows up to be a woman at the same percentile of height, what height will she be, right? So we are going to use our 77% that we had in that question, and we're going to go ahead and shade in. We assume it should be about the same size area as we see shaded up above. Right, so we're going to shade in 77%. Right, and this time we are looking to find a value or a height. Again, we are using our 77% from part A. All right, so this time we're going to enter our mean is 64. Our standard deviation is 2.5. we are going to leave it on our standard probability. We're going to select less than or equal to, and then we're going to put in this 0.77 over on that side. After we select compute, then we get an answer here. We get 65.847117. So we would say that this rounds to about 66 inches tall. And if we compare these two, again, in part A, we were given a value, we were asked to find a percentile or a probability, right? So we were asked to find a probability. That was a normal problem. Here, we were given a percentile, and we were asked to find the height, right? We were asked to find a value. This was an inverse normal problem. We still use our normal calculator, but we plug in different information, and then our answer is actually this one that lands here. Right, so the second part of section 6.2 is definitely related to the first part, although there are some major differences. Instead of, if we're kind of thinking about this, in one problem we're going forwards, in this type of problem we're going backwards.